Hello, everyone. Thanks for joining us today for our third day of the conference, or mini conference, or actually what it is just a bunch of meetups every day for 2 weeks. Every day we have a talk. So the first week, we're already on the third day. We're talking about career and data. And then on the next week, we'll talk about machine learning production. We already had a chat with Santiago and Deliana on Monday and Tuesday. And today we're talking to Andreas about how data scientists can improve their data engineering skills and learn how to build our own pipeline. Tomorrow, Roxolana will talk about two roles, big data engineer role and data scientist role, and the differences and similarities between the two roles. And on Friday, Elena will talk about building a machine learning startup. I want to thank all our partners for making it possible, for helping us with supporting us, supporting this event. There is a link in the description that goes to our conference page. You can check what they do, and you can also register for our second track of the conference. Don't forget to subscribe to our channel and join our Slack, where we talk about different data things. Finally, during today, if you want to ask any questions, there is a pinned link in live chat. Just go there, click on this, and ask any question you want. And this is it for the introduction. So let me stop sharing my screen. Yeah, are you ready?
Sure.
Okay, so now I'll just do that, and yeah, I'm also ready. So today we'll talk about learning how to build data pipelines for data scientists. And one of the most frequent questions I get is, I'm a data scientist and I want to build data pipelines. How do I do this? Finally, today, I'll know how to answer this question, because the guest we have today, Andreas, knows it better than anyone. So Andreas is a data engineer, and he calls himself the plumber of data science. He writes and talks about platform architecture, tools, and techniques that are used to build modern data science platforms. Welcome, Andreas.
Thanks. Thanks for having me. Hi.
So why the plumber of data science? Do you have any story behind that?
Well, I call data engineering the plumbing of data science, because when you look at data science, usually you see what the scientists do and like algorithms and so on. But in the background, there is a platform that you have to run, or pipelines that you have to build, and everything, basically an infrastructure that needs to support what the data scientists do. And that is usually, I say, it's invisible, but it's a huge mess when done wrong. So built like plumbing. So that's, and also it fits very good with pipelines, right? So
yeah, indeed. Yeah. So before we go into our main topic of plumbing and building pipelines, let's start with your background. Can you tell us about your career journey so far?
Yeah, sure. Yeah, my name is Andreas Kretz. I'm coming from Germany, and I've been basically within computer science all my life. I always loved computers, and I started like many people playing on computer games, and then I got into actual computer science and studied computer science. After that, I made a quick detour towards SAP consulting, but that wasn't my thing, and I came back into the computer science realm, where I started as a software engineer, and basically in a project where it was about the IoT, but the industrial IoT. So we were working on getting machine data in and analyzing machine data, and so basically that's where I got into the topic of where does or how I got into big data. Big data was a thing back then, and everybody was talking about big data, and we're doing big data. But I actually had the problem that there was so much data coming around or coming in that the standard tools didn't work anymore. So I need to find different solutions to actually work this out. And back then I started with Hadoop. So Hadoop was really the thing back then, and that really turned out really good. And so that's how I got into the field back then, big data, now data engineering, data science. I switched basically to data engineer, became a team lead for data engineering. This year I started leading a data lab, but since this month I'm basically went full time with teaching data engineering with my academy at learndataengineering.com.
Okay, cool.
And so
yeah,
that's how I got here.
Yeah, we'll talk a bit about your course as well. It seems like there is a lot of interest in data engineering these days, and you're probably, so since you said that you work with Hadoop, I think you're in this area for quite a while. So I think now these days there is a lot more interest than even a couple of years ago. So now I talk to some data scientists, and they say they want to get into data engineering. They want to start building data pipelines, not just learn to build data pipelines, but switch to data engineering entirely.
Yeah.
Do you have any ideas why it's happening?
Generally, the thing that generally happens is when you look back a few years, and I've saw this everywhere. People were starting with data science. They got themselves, they hired data scientists. They had some data laying around, and they basically analyzed the data. Had a few business ideas. Oh, we could do this, we could do that, and then they got to the data science track, and they solved the problems. But at some point, that's where we are getting more and more and more. Is people realize, okay, now I have this analytics methods. I solved the problem, but now I need to automate it. Now I need to build something around it, how to actually bring this into production. And that's why we see a lot more engineering. Is people leave the stage of like a proof of concept, and they get more into the stage of, okay, now we need to build something. We need to make money, or we want to make money. We want to build a platform. That's what I currently see.
So basically, data science becomes more mature, and companies realize that, okay, it's not just a one-time thing where we do something in Jupyter Notebook and throw it away.
Yeah.
Right? We need to automate it. We need to build all these data pipelines, and that's why people realize that okay, this is what data engineers do. This is what engineers do.
It's also from a scientist's perspective. Usually, you would think of like, okay, why should the scientist actually do that? Because the scientist should work on the science, right? Shouldn't work on the engineering. But it depends on like the structure of the project, or it depends on the structure of the company. If you're in a small startup, most likely they start small. They have a data scientist, and the data scientist needs to set up something. There is no engineer, and once it works, then they bring in engineers, and they make everything nice and beautiful, and But that's why also the scientists are getting more into this.
So do you think a company should first hire a data scientist and then data engineer, or the other way around?
I personally think they should hire both, but not like a huge engineering team, but like have a scientist, start, if you want to start really small, one scientist, one engineer. So the scientist can focus on the actual science, and the engineer can already think of, okay, how can we later down the road turn this into a product? So that, because that's usually a hurdle. Once the proof of concept is finished, how can we put this into a product? How can we build a platform or something around it? So if you can already get a data engineer early, then you're already ahead, But generally, the science part, I would say, starts with the scientist. That's the main thing. Usually, having some one-off data, usually it lays around somewhere. Somewhere somebody has the right CSV or the right database export.
Hopefully.
Most likely, hopefully.
So I mentioned that, company hired data scientists, and so this data scientist works on a proof of concept. and then they need to productionize it. And then if the company maybe doesn't realize that they need the data engineer, what happens is this data scientist implements the whole thing themselves, right?
Mm.
And what we usually end up with is a lot of code that is difficult to maintain because data scientists are usually not the best engineers. And I think this is where the question actually comes from. The question that at the beginning I mentioned, how can I, as a data scientist, improve my data engineering skills? Because sometimes it happens that data scientists need to do this. So coming back to this question, I am a data scientist. I want to learn how to build data pipelines. How can I do this?
I would say I think the problem isn't actually the coding. The coding is usually fairly simple. Like nowadays, engineering, you can most stuff you can do with Python, and if you're a good developer, at which you should be as a data scientist, it shouldn't be a problem. The actual problem that a data scientist has, or what a data scientist should look into, thinking ahead of how can I deploy this? How can I make this like bring this into a uniformed platform? Because what a lot of data scientists tend to do, like they choose tools for their platform, like they choose the packages that they use in Python. Like take this, take that, try this out here and that and that. But actually in engineering that doesn't work. You can't introduce 20 different tools. You need to figure out a few things that you select and then build everything around it. So that's the actual conceptual part is actually, I think, the problematic part for that a scientist needs to understand.
Why does it work? Why can't we take 20 different tools and make a platform from them?
I'm sorry, I didn't get the beginning part.
Yeah, so why can't so you said it doesn't work like this. So like in data science, we can take many different packages and yeah, just put them into one thing and do data science. Why cannot we do this with the platform? So why can't we take 20 different tools?
The problem is the operations part. Like somebody needs to take care of this at some point. And if it's the even if it's the data scientist himself or themselves, like okay, you have one data scientist and the data scientist needs to or sets something up, uses 20 different tools, and then and then the data scientist needs to take care of it if there are no more people, then it will be problematic because there are so many things to actually keep afloat. Very often some pipeline gets stuck somewhere, something quits, then you need to look it up. If you're using an open source tool here or there, you need to optimize configurations. So it's getting more and more complicated to actually have everything up and running, instead of if you focus in a few areas on a few tools that you use. And that's very important.
Mm-hmm. And to mention data pipeline, and we talk about these data pipelines, maybe we can talk a bit about this. What is a data pipeline? So why do we need a data pipeline? Why is my Jupyter notebook with all the code in it is not enough?
Yeah. Well, from an analytics standpoint, it's enough. Like you don't need to set up huge pipelines for different pipelines for the actual analytics stuff, most likely. In many cases, in other cases, if it gets more complicated, you need to split up your notebook and you create actually Docker containers out of it or whatever and deploy it. But let's forget about the analytics. When you think about the pipelines or the platforms, somehow you have an ingestion, somewhere the data needs to come from, and then at the other end you have analytics and the visualization behind it, or storage. And you need to actually build something to actually, for instance, I always put it into a few parts. One part is ingestion, another part is our buffers like message queues. Then I say the next part is processing frameworks, storage, and visualization. These are the different areas you need to look at. So if you think about like ingestion, how could you ingest the data? Either, for instance, you set up an API, or you set up an ETL job that pulls the data in. Like, what type of, you could have different types of processing frameworks.
Ingestion is, let's say we have a website and then the user can do a bunch of things on this website. So these events that we track and need to end up in our database. This process of getting these events and putting them into some place, this is called ingestion, right?
Yeah, you could say, okay, you have your website where the user is clicking and you want to track the clicks. So the website would actually shoot the event, and the event would, for instance, go into a message queue like Apache Kafka or Kinesis on AWS, and then it lays around somewhere there, and then you need to process it further. So you would introduce a processing framework that actually takes this message, processes it, and stores it somewhere. And then the next step would be the visualization. And in between there, somewhere you then use the analytics to actually access the data, do the analytics, and put the data back, for instance.
Yeah, so the process is, so first the user makes an event. So this goes to some message queue. Then from the message queue, it gets to some storage. I think this is what is usually called data lake these days, right?
Could be a data lake, could also be a NoSQL database.
Just some storage. Then these are all events, we need to process them. So then there is a job that takes the events and processes them, does some transformation, and then it ends up in some visualization tool, some dashboard maybe for analytics, or maybe this is something I, as a data scientist, can also take and use for building my models, right?
Yeah, for instance, yeah. It depends a bit on what you're doing. Are you doing event processing? Are you doing streaming, where you're immediately reacting to the actual data that's coming in? Or are you taking the data in a batch processing way? Because when you do streaming, you are going to take the data immediately, for instance, from the message queue, take it, process it, analyze it, make a forecast, and push the data further. Or if you're doing a batch process, then it would come out of, you would store it first and then you would take it out and then process it and then put it back in.
And in both cases, we refer to this bunch of things, this sequence of things, as a data pipeline, right?
Yes. I would refer this or call this a data pipeline, a complete pipeline where you have a beginning, where you have an end. Now you could argue, okay, where's the end? Is the end at the storage or is the end at the visualization? I mean, depends. But the important part is there are a few tools, a few parts that are there and they interact with each other. It's not just like there comes something and gets stored and gets, then at some point you take it out. You use a CSV file that you download from somewhere. That's not a pipeline.
Yeah, that looks like a lot of work, right? So something that a data scientist, just one person, probably cannot really implement. So it needs multiple people and a data engineer at least.
It depends where you are. Like if you're in a private cloud or in an on-premise setup where you have to install everything with open source tools, run everything on them, can be annoying. If you're on a cloud platform like AWS, Azure, or GCP, it's fairly simple to actually set up a message queue or set up a NoSQL database. The problem is, like as I said before, the problem is understanding, okay, which tools do make sense in this case that I currently have, and also what is always a problem is the actual I refer generally always as schema design, that you not like in a term of like a relational database, but you have to design how does the data look, how do you process the data, because it's important to understand, okay, in this step I need to do that, and then I need to do that, and my final result is coming in my document store. It looks like this, and so where are the problems there? What can be,
yeah. So maybe we can simplify it a bit. So let's say I work at a company as a data scientist, and we have data engineers. So the data engineers take care of this ingestion part. So they track the events, they put them into these message queues, and then eventually these events end up in our data lake or some other storage. And we need to use these events to build our pipelines for our machine learning models.
Yep.
Right? So the data engineers, they really focus on this lake. So they are not really helping us. Maybe they can help a bit, but basically we're on our own here. So we have access to this data lake, and we need to build a model. And yeah, so what usually data scientists know? They know Python pretty well. They know some SQL. They know all this Git, Bash things. And like when it comes to Python, we also usually know the so-called PyData stack, scikit-learn, NumPy, Pandas. Yeah, so with this knowledge, so how do we approach this process of building a pipeline to get our events from the data lake?
Yeah. So first of all, you mentioned in the beginning you're more alone in this as a scientist. Hopefully not. Hopefully the engineering already speaks to you, or you speak with the engineering to like already turn it in a way that the data gets stored somewhere where, or in a form that you can already work with. That's usually that's one of the main things that you need to look at. As a scientist, I would start very simple. I would focus on Python. You know Python. Don't go for another language. Don't go for something like Scala or Java, or like use what you already know best. As you said, like working with Git, working with Docker, most likely working with Docker, writing Python code. So I would focus on, okay, what tools are there? For instance, what processing frameworks could you use that already, where I can use my Python skills and build something up. Yeah, like an API you would then use for API building. You wouldn't use something with Java. You would most likely look at something like Flask or Fast API that I like a lot for prototyping. Like you would go that direction.
Yeah. So what are these processing frameworks?
Processing frameworks, you have to. I when I do the coachings in my academy, I try to show the students as, okay, there is this section processing framework, and this is everything that actually takes some data, does something with it, like analyzes it or modifies it, and then does an output. So in the processing framework, you could think of like, okay, what does some processing? A Python script that runs in a Docker container. I already count this to processing. Apache Spark. What is there? Apache Flink. Or if you're on the cloud, you could say, okay, AWS Lambda functions or Azure functions. You know, these things, or like, I would also use AWS Glue for that, where you can then, like, these are frameworks that are doing the processing for you. You just need to code them, right? But like, it's one area that you need to decide. So that is back to what we talked before. It wouldn't make sense to like do a part in Spark, then do a part in Flink, then introduce some Lambda functions here and there, and then you run a Jupyter notebook where you do some processing. It almost gets too complicated to actually run with a small team then.
Yeah, so basically this is a thing that gets in some data and out produces data, right? And it might convert something, or
for instance, it's there where you the processing framework, I would say, is there where you train your algorithms with. It's where you apply your algorithms with. It's where you, as a data scientist, do the pre-processing. These kind of things is where you filter out the data. Yeah.
And I think most of the time we can do, for most of these things except model training, we can do with plain SQL, right? Like data transformation.
It depends on, well, it depends on what you're working with. If you're working with some kind of a NoSQL database, running simple SQL queries might be a problem. If you're if you're running another like a more relational orient or relational database, then yeah, you most likely would use SQL to get the data, or just the simple files from a data lake. But within your framework, it could be that you use SQL to build data frames and then access the data frames via SQL. And yeah. SQL is still a big part in engineering and in science. Like everybody knows it. All the tools support it. It's one of the big things.
Yes. So what are the most common setup that you see, or the setup you would recommend? Let's say we have these tasks. We have data in our S3 bucket, for example, or some Google storage bucket. So these are, let's say, Parquet files that engineers prepared for us. And Parquet, for those who don't know, these are like a special format for files that is optimized for storing data. So we have that. So what would we use to actually process this data?
Well, giving general recommendations is always a bit problematic because you don't know what people are doing. There are a lot of ways of actually processing this data. As I said before, you could say, okay, I'm just this data is laying around. I'm just using Docker containers on how's it called ECS to actually trigger ECS jobs and read the data from the data lake, process it, and then put it somewhere else. You could even schedule this. AWS, for instance, has a scheduling service, basically Airflow in the cloud. Just forgot how they call it, but like you could or even say
they call it managed Airflow something.
Yeah, or managed data flows, or yeah, something. So you could set up something like this. You could also go like we said before. You could also build some within SageMaker. Use a SageMaker notebook and use that. It's like the possibilities are endless. And I don't want to cheap out of this question, but it's like
no, that's
a bit difficult.
Maybe a problem as well, because when you have so many tools for doing your job, you can be lost, right?
Yeah.
And maybe we can make it a bit more concrete. So let's say I want to build a model for predicting car prices, right? So here, let's say we have a website with cars and their prices and different characteristics of a car. And we want to build a pipeline for training our model, for predicting prices, and also a pipeline for applying this model.
Yeah.
And I don't know, to make it more concrete, let's say our data, the data is stored in MySQL, but what engineers did for us, so we don't use production MySQL, they copy all the data to an S3 bucket. So we have a replica of the data set. So we don't need to touch the production database. We have a copy of our data, and we need to build a model for that. So we use, let's say, I don't know if you have any preferences for the cloud. So I kind of mentioned here S3. But
I usually tend to, or I like AWS the most. I work with AWS the most, so I'm always thinking in AWS first.
Yeah, so we can maybe take AWS as an example. I think they're right now the most popular cloud provider. I think like 70%.
By far.
Yeah, something like this. I imagine that most of our listeners, they also, the chances are that they will use AWS are pretty high. Right?
That depends, by the way. It depends on the actual industry. It also depends on the actual location. I had students from the Northern European countries where they're looking at job descriptions, and it turns out actually more Azure for some industries. And then in others, like in the US, most of the things have AWS in them. So, but there are actually differences. Yeah. But yeah, to your example, so I'm not sure if I understood it correctly. Is there data coming in basically from two sides, from the website and from the SQL database that the
let's say so we have a product, we have a website
Yeah.
with cars, so we own it as a company. And what we want to do is we want to help our users when they are not sure what price to put. We want to build a model for them when they enter like the car make, model, etc. We just help them with suggesting a price. So this is a simple model.
Yeah.
And we have for this website, so it's backed by MySQL. So there is a MySQL database with all the data for all the listings. But we as data scientists cannot really go and take the access this MySQL database because it's a production database. So what engineers made for us is some sort of snapshot replica just for us to access the data. And now we need to build this model.
Yeah. Well, when you think about that, first of all, you need to think about, okay, how do I, from the analytics standpoint, how do I apply this then? Is that you most likely want to apply it so that when the customer searches, or as I said, it goes on the site, searches, that it already gets the predictions of, or the recommendations, right? So would you do that live, or would you put that to the categories so that the end result of your analytics is that always getting generated live, or are you doing some predictions and you store them somewhere where then
let's say I know it's going to complicate things, but let's say we need it live. So when a user creates a new listing and then so they fill everything in, and then once they do this, we suggest the price. So when they create a new listing, it's a live thing.
Okay, so you could say now there are a few methods you could do that. You could take the listing that is just been created. You could, for instance, send it. You could take it and you could send it into a message queue. So you stay in the event in the streaming lane, and then you have at the other side of that is where your actual algorithm is listening. And once something is coming in, the algorithm takes the listing, for instance, as a JSON, most likely. It's a website, will come as a JSON, takes it, and then it does the recommendation part, and then either stores it somewhere or like offers it over an API, or I'm not sure how you would want to do that. If the listing is already stored, then you could say, okay, I'm putting that to the stored listing. Very often what you see is that people actually apply or supply the analytics as an API. So the website would actually call an API, and the API in the background you would run your script, and that would then return the API. The return would already have the recommendations in it.
Yeah, what I mean is like what you described is the process of we already have a model and we want to deploy it. So this is how we use it. But what I meant is we don't have a model yet. We need to build it, right? And so what I can do as a data scientist, I can pull this data in, save it on my laptop, open Jupyter Notebook, do stuff with pandas, do stuff with NumPy, with scikit-learn, train this model, and I have this pickle file. And then 2 months after that, things change, right? So prices are different and we need to retrain it.
Yeah.
And I don't want to do this like every month. I don't want to pull a new data and execute cells in a particular order in my Jupyter Notebook, because maybe in a half a year, I will forget that I need to execute this cell before this cell because I accidentally
I know.
messed the order. So we need to somehow productionize it, right?
Yeah, and that's what I meant is with the Jupyter Notebook. Sometimes it's good. Like for this, you would actually create a proof of concept, or the first version of your analytics you would set up in a Jupyter Notebook, so you see that it works. And then the next part is, so now then you need to productionalize it. Most likely, if you're already in a Jupyter Notebook and working with this stuff, you could go and just take your Python code, put it in a container, put it in a Docker container, schedule this container to run on the data, I don't know, every day, every week, and just retrain the models and see if you find something better, if you find some different results for the current ones. And then basically this way you keep training your models, and then you store the model somewhere where you then can, if you apply them, then can most likely you store the model configs on S3. So when you apply the data, you apply the model, then you in your pipeline, you would actually have your script, and that script would pull the information from S3 and then just apply it, for instance.
Yeah. So we take our notebook, Jupyter notebook, we put it in a Python file, we put this Python file in some Docker container, and we go to our cloud and we find a way how we can schedule this script, right? And that's pretty much it, right?
Depends on how you want to run it. If you for the training, yeah, and I mean it can be really easy, the actual scheduling. You could use something like Airflow, but if you have some real simple, you could use CloudWatch and then schedule your basically. It's a bit with AWS, you need to schedule a Lambda function, and that Lambda function then starts your container. But it's like you could very easily set this up without having the whole a framework running like Airflow. Because let's and that's what I meant before. Does it even or the data scientists need to look into this to actually figure out, is it worth it? Because it's one more thing to manage, or can I live right now with something that is
and you said CloudWatch, and then as far as I remember, in Amazon there are multiple ways of deploying a Docker container. So you have ECS, right? You have AWS Batch, and you have SageMaker, right?
Yeah.
So you can just take any of these, put your Docker container there with your script, and then use CloudWatch to schedule it to run it every week, for example.
Yeah, I remember. I think we talked that SageMaker can get quite expensive. So
yes,
that's why I'm like always hesitant to say use SageMaker for everything.
Well, at least you can use AWS Batch, which I think is 4 times cheaper, if I remember correctly.
I know. I don't know.
Yeah. So in SageMaker, so they have the same instance types, but they have ML in front of them, and just having ML in front of them makes them more expensive. But at the end, it's the same types of instances.
That's logical. It makes sense.
Yeah, exactly.
Yeah. But the cool thing is, and what I like about that is what I mentioned before, like deploying your algorithm as a service. What you can do, that you deploy your algorithm actually as an endpoint with SageMaker that you have running, and where you can send the data to the endpoint, and the endpoint will send you some predictions. That is something that is really cool, and makes it a bit easier to do the management of the pipelines.
Let's make our example a bit more complex. So let's say we have this,
this script. Usually I do this with boards, where we draw on the board, so I don't get. Yeah, let's make it more complicated.
Yeah. So usually, let's say to get the data from this storage that we have, we need to write a couple of SQL queries, and we need to execute the SQL queries one after another. So first query would get us. So we have a lot of raw data. So the first query would get us like a smaller data set with only data we need. And let's say the second query would do some extra aggregation or cleaning. I don't know. So let's say we have 2 queries that do something. And then what we do at the end, this is what we use for training our model. We take the output of the second query and again, maybe do simple stuff with pandas, and then train our model. And we get this pickle file. So now we need to schedule this to somehow run the whole thing in sequence. So we need to run the first query, then the second query that gets the results of the first query, and produces some other result. And then we have the third job. that gets the results from the second query and trains a model and produces a pickle file. So how do we, what's the right word, orchestrate this whole thing?
It depends on how like I feel like I say always it depends on how complicated you want to make it. But like
the simplest
you
possible.
could do something really simple where you like build up a message queue, and once the first script is ready, it fires up a message into the message queue, and then on the other side is a listener that basically takes this message, and in the message you say, okay, where do I what part of the job already run, where is the data stored, and then the second part can take the data and can actually process and then writes back to the message queue. And this way you can use your message queue actually as in a streaming manner, where one job takes the information out. Okay, I need to do something. There is already, where does the data lie around? Do it. I'm finished. Write back, and this. So it's very often very easy to actually use queues for this kind of job.
I think I implemented something like this a couple of companies ago. When I left, what they ended up doing is discarding all that and moving to Airflow.
Yeah. It's. I mean, Airflow. These things are really, really strong and really good. So it makes sense to use them. But if this is a one-off thing, and like you need to build something quick, you need to start somewhere. What is good enough, right? And most likely for this company, as you said, you build this, it ran for some time, and it was good enough while you built it, and at some point they actually it grew over. They needed to have more logging behind it, more insight. Then you're moving to something like Airflow or something. Yeah.
Okay, and then
you don't need to go all out in the beginning.
Like for the first model, if it's just the first data science project in a company, you don't need to go with Airflow, Kubernetes, and all these big things.
Yeah. It's like it always depends on a bit on your timeline. What's the goal of the company, right? Where does the company want to move? Is this is it unsure, or is the company unsure where to move, or is this going to be a platform where like a lot of projects are going to work on, and then it's good to have then I would set up everything already. Otherwise, start small, start agile, and you can always build something, add something to it afterwards. That's also how I usually talk with my coaching students. Like, build something first, build it simple, and then at some point add more stuff to it. Like start with a Lambda function, and then use Spark streaming for that, and the next step. So in every area you can escalate and make it more complicated or different.
Yeah, so we have a related question from chat now. So
okay, cool.
I think we already discussed how we can do this from a Jupyter notebook, like how data scientists can start their journey towards being picking up data engineering skills. So that part we discussed, but the second part of the question is how to learn the DevOps and software engineering skills that you need to be able to implement this.
Well, the DevOps skills, that's where the tool selection comes in. That you understand, okay, how can I actually bring this into production? How do I manage my code? How do I that's there are certain tools that I see around all the time, like something like GitLab. A lot of people use GitLab as their code repository, and actually for building then their code and deploying their code in production. That's something I see a lot. But generally there are many tools out there. It's always the same, like most of that. If you use Jenkins for building and so on, it's most likely does the same stuff. Right? So
your recommendation would be just to pick any tool and try to learn it?
I would pick something that fits to the rest of what I've just built.
Mm-hmm.
So that's what I meant in the beginning. Like, you need to understand what tools do I actually want to use, so you don't go overboard, and in this case, so that everything fits together. So you're actually using the right tool to manage your code, to deploy your code, and it fits to your actual deploy to your actual production environment.
Yeah, so I guess if I'm a data scientist and I don't have experience with these kind of things, I would need to talk to a data engineer or somebody who's dealing with infrastructure to actually help me and guide me through that. Right? Because how do I know if this is the right tool if I haven't used previously?
There are a few options that you can do. First of all, how I always go at this, I look at the this is very lame, but I look at the documentation of the tool, like what can this tool actually do, and then I search for how do you call it in English, not proof of concepts, like examples that where people already did that, what I wanted, what I envisioned to do. And if you already find some examples, here, and you can just do this on Google, like, they did this, this, and this, and you find some quick how to-do lists of what you need to do, or tutorials, then most likely you're already on the right track. And then if it's an open source tool or whatever, just set it up in a dev environment and test it out. And if that works, it looks already good then. Then you're most likely on the right track.
So speaking of the example we had with this building a model for price prediction. So let's say if we decide to go with AWS Batch and Lambda and whatnot, so what we can do is we can go to our favorite search engine, put the queries there, like model training pipeline, then the name of the tool, AWS Batch, Lambda, and then we hit enter. And then we see what are the results. Then maybe adding a word tutorial at the end might help. And you end up on towards data science on some other similar website where there is like almost a step-by-step tutorial with all the steps you need to do.
Very often you find this, like in your case, like how to use AWS Batch to analyze S3 data or something. And then most likely you're finding 10 blog posts that already do the exact thing that you want to do. And then you just insert your code. Of course, your analytics you need to write it, but like the frame around it, how to get to the data and where to write the data, most likely you can already extract from this. And
so I guess the short question to this answer, how to learn DevOps, is just do stuff. If you don't know, Google them or use your favorite search engine.
Like as I use the search for what different tools are there, what capabilities do they have, how does that fit to the rest of the platform, and then just try it out. I'm always going for, okay, let's try this, because usually when you actually do it, then you're finding the holes in the whole thing. Like, this doesn't work that way, this doesn't work that way. It's always the same. Unfortunately.
Do you think data engineering skills like Hadoop and etc.? So this is another question I'm reading. Like Hadoop, Docker, Cloud, they are necessary for students who are looking for internship, or like do they need to have these skills to get their first job?
I think for internship, if you can code Python, if you know your way around SQL, you should have learned this during study. If you have a bit of an idea how computer networking works, so like DNS, IP networking, if you have an idea about this, then for an internship you're good to go. That I mean, for becoming a junior data engineer, I think you need some experience on some kind of a platform. Most likely it makes sense to use AWS. I would start by using AWS, And that's why I, for instance, in the academy, I build the AWS capstone project first, because I think that's the most important thing. And we use that in the coaching as well most often. And then the second part, I think, is for the open source tools. Just use a few open source tools like Kafka, Spark, and like MongoDB, most likely. That's some stuff that is around there everywhere. Makes sense. And then you should, if you then don't get a junior role, I don't know. Like, I would most likely hire someone who has that as a resume. The important part is documenting it. That's what I always. That's what I say to my students. Document your stuff. Never just do a AWS or AWS certification or whatever. Never just do the certification. Always create a GitHub, put up some information, put up interesting stuff that you have learned. You need a track record. You need to have a track record. You need to have a professional profile, and not just like a LinkedIn page, but like a professional profile that has some experience, where you show some experience.
Mm-hmm. And yeah, so in this question, there is a bunch of things mentioned under the data engineering skills, which are Hadoop, Docker, Cloud. So Docker and Cloud, I don't think you would argue that these are important things to learn. What about Hadoop? Do people still need it, use it?
It depends. I see the trend that Hadoop isn't what it used to be, because the cloud platforms got so strong and they innovated so fast. Most companies nowadays use a cloud platform. Yes, you have stuff still laying around or still working on Hadoop. Most very often in bigger companies where they have private clouds that they're running, and then they're running Hadoop. I think for getting a role or for learning, it can make sense, but it's not like one of the primary thing. The cool thing is coming from Hadoop, you see that everything on the cloud platform, that is basically the same stuff that you do on Hadoop. It's basically always the same stuff. You're running on a Hadoop platform. Just it has a different name and works a bit differently. But like it's very, very interesting how these tools fit together. So yeah.
And we have a question from Julian, or Julian, I don't know. But the question is about your academy, and you mentioned it a couple of times. So first of all, what is the link to the academy? So how can people find it?
LearnDataEngineering.com.
It's one word, right?
One word. That's where everything, where I have the academy, where I do the coaching. I at some point I started with YouTube. I don't know how many years ago. 4 years, 3 years. When did we talk, Alexei? Do you know the year?
2 years ago, I think.
2 years. So maybe then 2.5 years ago, I started with YouTube. And actually, on YouTube is always you make videos, but it's not like one like. You can't put up a journey, or you can't say, okay, learn this, and then it will work out. And so last year I actually decided to, okay, let's try to build a curriculum for actually learning data engineering. It turned out it's harder than I thought, because what we talked about before, like there are so many tools and you need to focus on some stuff. But in the academy, I created a course, a step-by-step course that starts basically giving you the fundamentals of actually what is data engineering and what do you need for actually starting. And then we go through basics of platform and pipeline design, and then fundamental tools, and then capstone projects like the AWS project. We are having one more coming next week about Azure, an Azure course, and I'm currently working on another one, as I said before, with open source tools, MongoDB, Kafka, Spark, and so on. So if you're interested in or if somebody's interested in data engineering, check that out, or check out one of my 300 videos on YouTube or something. I don't know where we are currently.
I think if you Google for the plumbers of data science, the first link should be your
Could be.
YouTube channel.
Could also be, yeah.
Or your name. So,
yeah, my name as well. My name and data engineering most likely will bring something up.
Yeah. So from what I understood by talking to you now is one of the most important skills to have for to pick up data engineering for a data scientist is to have these cloud skills. But cloud skills is such a broad thing, right? But there are a couple of tools that are useful for data processing. So I'm wondering if you can give a good recommendation how to approach learning this. So I usually suggest to learn things by doing projects, and maybe you can recommend a project that people can build to pick up these cloud skills.
A general project. Well, I don't want to beat my own. Like this shouldn't be a sales thing. I have a project using e-commerce data on AWS to actually do it. But generally, I think it's more the general approach is the more important approach. I have on my website you find a link to the data engineering cookbook. And in the cookbook I have, and also on my YouTube, I have videos about my data science platform blueprint. And this will help you a lot to actually see these areas that I talked before: connect, buffer, processing framework, store, visualize, and then actually select tools for each of these, and then build a pipeline, and just start by using this, and use a data set from Kaggle or whatever. You don't need to go really big. Use a small data set, 40 megabytes, whatever, and just start applying this and building a platform, building some pipelines on it.
I think there are a couple of competitions on Kaggle where it's not just one CSV file, but they have multiple CSV files, and then you would need to actually do a join. So like, I don't know, 4 or 5 different files, and then to build this final table, let's say you need to do multiple joins. I think these kind of data sets would be most interesting because this is what we usually do at work. So it's not just data already prepared, but we need to do a couple of joins, a couple of, a couple of things on top of that. I think one of the competitions where it was, Outbrain click prediction, I think, but there are a couple of them. So, and these click prediction competitions are quite interesting because they have a lot of data there.
Yeah.
So but 40 megabytes, I think, is also a good start.
The thing is, you don't need to, for learning it, you don't need the huge data sets. What is going to happen is when you use huge data sets, first of all, the loading times are going to be terrible, that everything runs long. Then you cannot easily look into the data. Then because it's big, the cloud platforms are going to cost more because you need bigger systems and everything. Don't need that. Use small data. I very often in the academy or in the coaching, we use a simple e-commerce data set from Kaggle. Because even there you can understand, okay, why actually, for instance, would you go the NoSQL route and not a standard route of building a relational database and so on. So that these are it doesn't need to be complicated to actually start. That's if you're listening to this and you only remember one thing, start simple and use a simple data set. Don't go all out, and you only get frustrated. And most likely use the cloud for beginning.
So don't start with Kubernetes Airflow and 1 terabyte of data.
No.
Good advice. I know it's almost time to it's actually time to finish, but there is one interesting question, and maybe we can take a couple of minutes to answer that. Maybe it's a tough one, so let's try. I'm trying to convince my company to start a data science department. What is the best tool set to show results with my current $0 budget?
With your current zero, well, first, so if you need to, I don't want to discourage people, so I need to be a bit be careful. So if you need to convince somebody to run actually to use data science, it's already a bit of a problem. I would go the route and just do it. If you don't have money and you can spend some time, just build something locally. Use a few, like you don't build a platform, don't build pipelines. Do a proof of concept. Like just have, as we said, use a notebook, get some data, and show what analytics can actually do. What analytics can deliver, and put a number on it. How much data, how much money will this bring? People don't care about data. How much data do you process for that, or how long did it take? How much money will this bring in? It's even better than how much money will we save through that. Most likely, revenue counts. So if you can show a good result, and if you can show a rough timeline, how much revenue this can generate in the future, then most likely, if you talk to the right people, then something will move. Otherwise, forget it. Try it, but don't like.
Okay, so you need to turn this $0 budget into something greater than zero.
Yeah. And the cool thing nowadays is if you have a MacBook or whatever, you can already start doing data science. Right? It's not like you need that big machine, that $10,000 analytics PC.
Mm-hmm.
You can start small.
And with AWS, there is this thing called free tier, right? And which allows you to do some Lambda stuff for free. Then you can get EC2 for free. Right?
But actually, yeah. But how much does that help you?
Yeah. Well, at least you can.
Most likely, you are going to run tests of it for a few days, or train models for a few days.
Yeah,
then
right.
Your free tier is over. So you have a computer at work. Use that. Start a training at the end of the day. Let it run throughout the. We did all this years ago. Like let it run over the night, over the weekend, and hope that something comes up on Monday.
That's interesting. So last question, how people can find you?
You can find me on, just Google my name, Andreas Kretz, or Plumbers of Data Science, or Learn Data Engineering, on LinkedIn, on YouTube, on Instagram. Instagram as well, Andreas Kretz. I have 1,400 followers.
Okay. I don't use, but
I've been trying so hard on Instagram. Instagram is like terrible.
Okay.
Yeah, but you can contact me there as well.
Mm-hmm.
Okay. And we have a Telegram chat group. So if you go to learndataengineering.com, on the bottom is a Telegram chat group, Team Data Science, I call it, where we can chat about.
Put a link in the description. Okay.
Yeah.
Do you have any last words?
Thanks for inviting me. It was really fun talking to you, Alexei. I hope a few people get into engineering now.
Yeah, I hope so as well.
It's a cool profession, and I love it.
Yeah. So I'll put all these links, maybe not right now, in a couple of hours, but I'll do this. So check the description. And we have a couple of more talks tomorrow and on Friday. Check them out. Thanks for joining us today. And thanks a lot, Andreas, for sharing your experience with us. So now, next time when somebody asks, how can I build a data pipeline? I will share this video with them. And hopefully they will not start with Kubernetes and other stuff, but that's something simple. Yeah. Okay, right. Thanks. And